Hi. Um, I figured I'd get kind of excited. I got my holiday shirt on here, my Nakatomi Plaza Christmas party shirt, if anyone gets that.
I was admiring that.
Okay, so I want to talk about this crazy car radio project that I'm trying to finish up here. All right, so let's see. Is this going to work? Oh, there it goes. All right, well, you guys know who I am. I'm originally from the cryptography privacy world. One of the original cypherpunks, worked on PGP and stuff like that. And back in the 70s, I was kind of a homebrew computer hobbyist. And the relevance behind that is that this is one of those homebrew things. Oh, dog needs to come in. Hold on. This is one of those homebrew things where, you're wiring it up and whatever. And I'm also a car hacker, meaning that, I take apart, I've gotten deep into the CAN bus and how the car stuff works. And since I retired from the tech world, I started working with the search and rescue teams locally. So I said, hey, I've got this Jeep. And it's an interesting project because I started off with a regular Jeep Wrangler. I replaced the motor, put in a Chevrolet motor in it, which is really an interesting thing these days because there's two separate CAN buses on Jeeps now. Well, in my case, right? There's the Chrysler one that talks to the Chrysler ECU and does all the internal stuff. But now that I have this other motor, there's a completely separate CAN bus that the motor itself and the transmission use. So to get things like speedometers working and all that stuff, there's an interface box that these folks at Motec made that takes the GM data, interfaces into the cluster, what we call the dashboard, and controls things like the speedometer and all that stuff. So, there's a lot of interesting data going back and forth. Now, it's just a network, okay? I mean, as far as I'm concerned, people make a big deal about it, but it's just a network. So what I wanted to do for a project is, it has a stock radio. I don't really like the stock radio, and it's kind of wearing itself out. And there's a bunch of things that I would love to have seen Chrysler or whomever improve on. And one of the things I really would have liked was, it would be nice if I could, instead of just tuning FM, I could tune some of the VHF, UHF channels. It would have been nice if it was a scanner. And one of the things that really annoys me is whenever you get one of those engine check lights, I would love if the thing would tell me what it was instead of having to pull up my Autel box here. There's a little device that I use, one of these little devices here for actually talking to the car and talking to the CAN bus and figuring out. It'd be nice if this thing did all that work. So, let's put it a GPS. Now, everything I'm going to talk about, I've written about. So there's this link there. I'm Vin the Wrench on Substack. And, I've written all about this stuff. So, why build this thing, right? Well, I'll start with the fact that I don't like most of the car radios. And, it's like when you're a hacker, you think you can do it better. So one of the things that bothered me about replacing the car radio is that today, they just don't have a simple on-off switch. They're fairly complicated. You want to turn something off, but you've got to hit a bunch of buttons. And that's pretty difficult. I also said I want to be able to talk to the CAN bus and diagnostics. I would love to do something with a little bit of GPS. Now, I know you can do these with separate devices, and I generally have to carry a GPS with me. But it would be nice if the car knew a few things. And, to do a radio, I said, look, this is a great opportunity to start playing with software-defined radio. This has a lot of potential, not just as radio, but picking up some of the data that, you could pick up the tire pressure sensors. You can pick up, hey, I can drive around, read people's gas meters and stuff. It's awfully funny. So there's a bunch of folks that have done this kind of stuff. Open Auto is a really interesting thing. People have done some cool things. They use an OLED display. They have Raspberry Pis. It's cool, but it didn't quite match the look of what I wanted. I'm trying to maintain that sort of vintage look. So I said I was going to go with a vacuum fluorescent display. And again, it's just my personal taste. So the problem is, how do you do this? You know, sort of when you look at it and you pull it out, you realize that it's sort of a double din. But you know, Chrysler, Dodge. When I say Chrysler, Jeep, by the way, is done by Chrysler. Chrysler, Dodge, whatever. They use their own form factor. It's sort of a double din, but it's not in the size. So the easiest thing to do was for me to just find a wrecked radio on eBay, strip it out completely, you know, and build my own box on top of it. So what I did is I stripped it out, gutted it. Now I have the right form factor. I took off the front panel and I made my own design. Had a buddy 3D print a frame. We took the existing frame, measured it, and said, okay, that white thing in the front, the frame of it. And I had to also reverse engineer the wiring. So before I go on, I gotta tell you, nothing is documented from the car manufacturers that you can get to, right? So Chrysler is incredibly secretive about what they do. There are some diagrams, you know, if you're doing mechanical work, but they're really poor. And so I've had to reverse engineer a lot of it. And the funny thing is, you know, every year is slightly different. So somebody will post a diagram and it's not even close to what it would look like that particular year. So, all right, hold on, I want to close this window. Shoot, how do I close this thing? My gosh, all right. If I do this, oh, of course it's gonna quit. Sorry, there we go, we're back again. All right, so I had to reverse engineer the wiring. Okay, so what's the hardware? Well, I started with a Raspberry Pi. When I started the project, I happened to have a 4B, and this is way overkill. I'm pretty certain you could do this with a Pi Zero, you know, Pi Zero 2. It would have been fine. The deal is I happen to want the USB ports for what I was doing, so this was not a bad device to use. And again, at the time, these were not expensive. You know, the world's changed. Waveshare made it. I looked at a couple of different CAN adapters. There's some really interesting ones. Waveshare is a really neat one because they went to the trouble of isolating it, and they actually have physical isolation on the board if you look at it. And again, go look up my stories on Substack where I talk about it. But they did some pretty interesting isolation, electrical isolation. Argon made a neat fan. I didn't use their software, but I like their fan hat. It fits really well. You know, it's kind of cool. You can control the speed. You know, we could build this yourself. It's nothing hard. The GPS is interesting too. I managed to grab a board from SparkFun. The U-Blox GPS is unbelievable what it can do, and I'll talk more about that in detail. And I grabbed an SDR. I got a fairly reasonable one. Again, these not super expensive, but the Smart T was really was kind of neat. Okay, the display itself is interesting because these are really hard to find. There's one of the distributors in England there. Let me think what they're called in England. They managed to carry the Noritake display. You know, if you try to buy one now, they're like out 6 to 8 months. So I think when they had the supply chain problems, there's probably like 1 or 2 chips that they got out of China that's hosing them down. Hopefully they learned some lessons from that. But I like that display. It's a 128 by 64 display. You can do graphics with it, but really limited. And you know, if I had more time, I would probably build my own, grab one of the VFDs and build my own card behind it. Because talking to their display was a bit of a challenge. I want to say something cool about the knobs and the LED rings. If you haven't seen what I've talked about before, these folks, Dupa, made an amazing set of control knobs and LED rings. They're out in Italy. They're not expensive, and there's a lot of cool potentials. I've seen people use it for music stuff, where they use it for music mixing, and the LED rings are just kind of neat and they look cool. And the rest of it was, you know, nothing special. I did have to build a power management board of my own, and what you'll see is that sort of the thing in the back. And I'll talk a little bit about those things in detail. This is all None of this is scripted. This is all C, C++, using LLVM. You could use the GNU compiler, it's fine. I happen to like that compiler. I write code in an interesting way. I build it on another computer. I happen to have a Mac here, and so I'm building it on a Mac using Xcode, but it doesn't matter. It's just a compiler. Links it all together, and then when I have it tested, at least get this. I can't test any of the hardware, but I can test the logic of the software. Unit test it all. I will throw it over to the Raspberry Pi and recompile it there and run it. The VFD is hooked up over a serial port. Xi2C, blah blah blah. So what the software does basically is it looks at the knobs and the rings, and looks at the knobs and runs a state machine that drives the radio logic. One of the challenging tasks is it has to read the SDR off a USB and filter that. So if you haven't, maybe I'll get into SDR in a minute. I'll get some detail, but you have to filter and demodulate all that yourself. That's just C code. And so one more thing I'll add that's really cool is I did manage to add AirPlay using the SharePoint sync stuff. And this is a really neat piece of software. That's the one thing that I ended up taking, as open source and using. He did a really good job. So all of my code, by the way, is up there on GitHub. It's all free, whatever. All right, so the first problem I had was I built this, building this box. What you can see in that picture is the power management board in the background. There's right in front of the power management board is the CAM interface. And then there's the Raspberry Pi with the big circle around it. And the problem with it is the way the Pi is designed right now, the GPIO, the 40-pin connector, only connects upwards. So if you want to add a hat onto the device, and you want to put a fan on top of it, it kind of defeats the purpose of the fan. The fan is just cooling the hat. Okay, so so I had to take the board apart and say, and I pretty much had to desolder the 40-pin connector. And let me tell you, that is a problem. That is a serious piece of work, because that's multi-layered. The ground planes are really, the soldering to the ground planes are really, really hard. So you need to really control your temperature and, use a solder sucker to pull pin out at a time. So I basically sheared off the connector and then, heated up each one and pushed it through. It did take work. And again, I said I was a computer hacker, so I'm used to doing this kind of stuff in the past. So I changed it around and stuck an adapter so that I could put a female underneath it and a male on top of it, and then mount the fan directly above the Pi, and then build cards underneath it. And it's like one of the things I really wish they had done, either ship me the board without a connector and let me do it myself, or consider that people are going to do this. I mean, I get it. They probably didn't assume people were going to build cards, whatever. The display board, there's the VFD display and those really cool knobs. And at some point, I should probably make this into a PC board. I have it hooked up over USB, so there's a little device there that grabs the USB and pulls out the serial and talks to the display board. Part of it is the display is 5 volts, so it makes things a little easier. The illuminated knobs and everything, they're I2C, and there's one more wire that's an interrupt line. So when I rotate the knob, I get an interrupt rather than sit there and try to pull it all the time. Oh, yeah, there's a little video. So what's really cool, I don't know if you noticed that, is that when I was turning the knobs, I had the LEDs follow. I wrote some code to have the LEDs follow the volume control knob and then dim itself out once it started. and the tuning knob will sort of follow it. You can do whatever you want, and it's multicolor. All right, let's see if I get to the next page. Yeah. Okay. So GPS, I'm using the U-Blox M9. It's a pretty cool chip. If you guys want to do any GPS, I really like this chip. You can talk to this thing, serial port. You can either use NMEA or UBX, their own protocol stream. UBX is neat. It's this great, it's a binary protocol. You can do some fascinating things with it. I wrote extensively about this and the problems I had talking to it. Supposedly you could talk I2C to this, but not to the Raspberry Pi. Raspberry Pi's I2C doesn't understand what's it called? Time delays. Like you can't slow it down or put gaps in the time delay, and it's in the spec. But so what I did is I ended up using the software version of I2C, and that worked. But ultimately, I ended up just hooking it up, over the serial. It worked well. One of the other things I do is I've written code that will calculate distance and heading to a waypoint, and that's a whole cool piece of science on its own. Go look at what I wrote about that if you ever want to do it. There's some pretty fascinating, simple ways to do it, and it's all high school math, but well, what maybe kids don't do in high school anymore, but it is in fact what we learned in high school math, and pretty cool what you can do. I will tell you, GPSs are not a compass. You have to move and then figure out what's happening as you're moving to see whether which your heading is. So one of the things I did here is I blotted out the UTM that I was at. We use UTM rather than lat long. One of the things I did here was I took a particular waypoint, the dog park, and I said, oh gosh, here's the distance, here's the bearing. And as I was driving, I calculated what direction I need to go in to hit that particular bearing. So that's what the little arrow, that 274 degrees guy is. That's telling me go that way, 274 degrees. I don't know. I mean, it was just neat. It was an experiment. Okay, the can, and you'll see that little picture, no bus. That's what happens when you screw up the car network. I had two different kinds of networks. There's a really, if you want to mess with CAN, the MCP 2515 is really a common controller. Everybody uses it. What's neat is if you just grab a card with that controller, or you just want to hook it up over what do you call it? The SD, the serial, not the serial line, the SPI lines. There's a lot of utilities, and there's something called CAN utilities. And what you can do is you can read what's going on in the data bus. You can send things out, and you can sniff, which is kind of interesting, because sniffing basically says, I'm looking at what's on the bus. I'm not going to contribute. And then you can say, I want to filter and just look at these particular packets. So CAN's kind of a simple network. Basically, devices transmit. Devices broadcast. There's no point to point. So basically, if I'm the engine telling you the RPMs, I'm broadcasting at a certain address, and you need to listen on that address to see what the RPMs are. The way you figure it out is kind of interesting. If you want to reverse engineer it, I wrote a little bit of code that would display changes. So I have it running. I'm looking at all the messages, and I see which ones have changed in the last couple of seconds or second, and highlight them. And then after a while, you start realizing, okay, some of them are changing all the time. Oh gosh, this one's changing once a second. This must be the clock. Okay, here's another one. This changes when I open and close the car door. Well, these bits must be the right door, and this bits must be the left door and stuff. So you have to actually reverse engineer that way. Step on the gas, watch the RPMs go up and down, stuff like that. If you want to write code, in this particular case, I use something called SocketCAN, which is a bridge, which is a library which bridges it into Berkeley sockets. So you can write standard C Berkeley sockets, and you could do this in Python too. But just write like you would any other network code. Yeah, okay, so I have to reverse engineer those. So what can you do? Yeah, you can get the diagnostic codes, and that's kind of cool. So when something goes on, you can say, hey, here's the diagnostic code. And I kept a database of what I know as diagnostic codes. Um, you can also monitor vehicle state. And that means one of two things. You can either listen for, if you figured out what it's transmitting, you can listen for those devices and say, listen to those broadcasts and say, okay, this one must be the RPM, or this one's the coolant, and I can listen to that. Or you can poll it using the ODB protocol, which is typically how these little devices, the Autel boxes and stuff do, that they poll. So they send out a command, and that the ODB stuff is fairly well documented. Automobile manufacturers are supposed to agree on certain ones, but there's also secret codes that they don't. That so, like for example, if you want to know what the secret codes are for the Chrysler stuff, like how to talk to the radio, you pay Chrysler tons of money, and they gave you a document and non-disclosure, and then you can put it in your scanning device. But I just figured that out. The reason I care about the CAN bus, and this is an interesting problem. So the problem with the Raspberry Pi is it doesn't have a sleep mode. So, when I'm done with the radio or I leave the car, I shut it off. I need a way to shut off the Raspberry Pi. And then when you turn it back on, turn the thing back on again. Now, you can figure shut off fairly easily. Like a lot of people say, I'll just turn the key. And the way a lot of people solve this problem is they just look at the ignition line. And I don't think that's really quite adequate. It's probably good for an older vehicle because that's all you have. But if you think about it, sometimes because it takes so long for the Raspberry Pi to come up, I would love to have a head start. So what I did is on the power board, there's a device that will sit there and listen to the CAN bus. And when it sees activity, because what happens, the bus gets quiet after a while, it will turn the thing on. And then when the bus gets quiet because there's no more activity, you've shut the car off, you've locked it, you walked away. I will time out after a little while and say, okay, there's no activity, shut the computer down. There's a couple other things I have to do because I'm a radio and I'm using the existing amplifier. I have to talk to the amplifier and tell it like, right and left and fade and stuff like that. So I have to send it the right commands. All right, so I have this power board. And the power board, my goal here is don't drain the car battery when you're not using it. On the other side of the power board, the one that's not shown here, there's a DC to DC converter that takes the 12 volts and gives you back 5. On this side, what I did was I wanted to set up a relay that I could turn on and off the power going to the Raspberry Pi. And turning it off is, basically the Raspberry Pi has got a GPIO pin that you can set up so that it will change state when the Raspberry Pi is ready to shut down. So when you've actually completed shutdown, you can tell the relay, hey, flip and shut off. And I have a device that's listening to the CAN. The TJA 1049 is listening to the CAN bus, and it's one of the chips there, one of those little green chips. It's listening to the CAN bus. There's another one that's a 555 timer, and I just set it up so that if I see CAN bus activity and turn the relay on for a certain period of time. And this is a bistable relay. That's the other part that's interesting. I'm not engaged. Oh, so if you're going to build anything with relays, be careful about engaging them all the time. They get hot over time. And for most cases, we don't care about things like that. But if this is in a radio box and I turn a relay on, that magnetic coil uses some energy. So one of the things you can do is you can hook up something with a capacitor, an RC circuit that will spike, pull the relay down, and then hold it. But instead, what I did was I found this bistable relay that Hella uses for glow plugs. And basically you tap it one way and it resets, or tap it the other way and it sets. And so what my detector does is when it sees CAN activity and the system was off, it will turn the relay on, it'll set it. but it's also gated so that it won't keep hitting it once the thing is set and once the power's on. And then when the Raspberry Pi says, "Hey, it's time to shut off," it triggers the relay offline, and that clicks the thing off. The chip on the right side there is a USB to serial device, and I have that hooked up to the console port, because what I want to be able to do is plug a computer in occasionally and talk to this thing. Oh, you're building car radio. I'm not on the internet, okay? So I have to do certain things like figure out what time it is. I can set the time or correct the time with the GPS, but when you power up, you need to know what time it is so that you don't mess things up. If you're creating log files or whatever. So I have a real time clock in there. But that said, I want to be able to monitor it. I don't necessarily have Wi-Fi hooked up. So if I want to do some debugging work, I can just plug a console, basically plug a USB cable in and look at that. And that's what the USB adapter is for. Oh, hey, I want to know what the temperature was. Really other cool, simple project. I did a one-wire interface. If you don't want to, this is another cool thing to play with if you like to do Raspberry Pi stuff. Raspberry Pi's got some pretty simple API for doing this. You can take one of the data lines, and I think in this particular case, let me see, what did I use? Oh gosh, one of the GPIO lines, it might have been like 6 or something, GPIO 6. I used for a one-wire interface. And so you give this thing 5 volts, these devices, one-wire interfaces and ground, and you just take that one wire of data and feed it into the Pi. And if you use the one-wire file system, okay, what they did is they use a Fuse file system in user space, Fuse file system, and somebody wrote a client on top of Fuse that did one-wire file system. And so what happens is, if you want to look at the temperature, like in this particular case, I know that there's a device out there. I can go off to /sys bus w1 devices, and then there'll be a list of devices there. And in this particular case, I found, oh gosh, there's one file there. There's a directory called 28 something something. And then if you look in that subdirectory there's a temperature subdirectory. There's a file called temperature, and in there is the temperature, 34.625 degrees. And it's that simple if you want to read temperatures. They're pressure sensors and other cool things. But if you haven't played with this is a whole cool thing to play with on its own. Oh, SDR. Wow. Okay. So this is an entire subject worth an entire talk. But I'll just say this really fast if you haven't played with it. SDRs are really interesting because they're not necessarily what you think of as a hardware, as an old school tuner. They tune a frequency band, and it takes the signal within that frequency band and converts it to what they call IQ signals. And that, again, go look at my discussion. IQ is pretty interesting. It's basically, they plot the signal. So like, for example, if you look at AM, it's this waveform, this amplitude waveform. They'll plot it on a 2-dimensional graph as not over time, but in imaginary and real coordinates. And to calculate things, so it's basically a polar coordinate. And to calculate like what the amplitude was, you just look at the distance from origin out to that particular point. And so what you can do that's interesting here is that you can demodulate stuff by saying, okay, here's the particular range of frequencies I'm interested in. And you demodulate it with software. You can figure out whether, you can filter it with software. You can figure out, okay, if this is AM or FM, you write software that demodulates it slightly differently. And digital signals are also pretty cool. And so you can look at a lot of things. And so what you see right there is the bottom, there's a Fourier diagram, of a waveform, and you can see the little FM broadcast signal right there in the middle. And at the same time, you're actually seeing those other signals, but you filtered them out. So I recommend, if you want to at least dabble in this, look up this course called EE26N that was put out of Stanford. And this guy just talks about the data that all your devices leak. And it is a fascinating discussion. Just Google E2610. And Michael Osman of Great Scott Gadgets did a great series of videos on YouTube about how SDR works. He did a section on just the whole description of like how imaginary numbers work. And it was fascinating. It was like, I didn't realize this. I wish I had known this in school. Anyhow, so the cool thing about the SDR is you just write code and change how it works. Given that, I said, hey, this is neat. I wrote a radio program. I basically wrote something to demodulate FM. And, it has all the usual features that you'd expect. Like I could say, tune all the channels, or only tune in when I turn the knob, only tune in the known channels that I programmed in, or the preset channels that I'm interested in using. Known channels requires me to I basically have a table. I've looked at a particular area and I said, okay, here are the known channels in that area. Same thing with UHF and VHF. It's just filter code. So there's nothing that makes it any different. When you're looking at the UHF channels, in the US, our bandwidth is a little smaller than I believe in the UK. So I have a slightly different filter, but it's just filter code. So one of the things I've done is, since I know the channel frequency, I can display something that says, oh, this is what this is. With FM, there is a sideband that they do transmit channel information. I didn't get into that yet. I just use a table right there. So in that diagram, in that first picture you see, it shows that it's FM. Here's the frequency. There's a banner that says this is the channel I'm interested in. The things in the top, the 70 and 83 degrees are the indoor and outdoor temperature sensor. And at the bottom, I'm showing a signal strength. And so that's -2 decibels, the weakness of that. -26 decibels. And the one below it, for example, I've tuned into, the Jackson County Sheriff's Office, and it's below my squelch level. So the squelch indicator came on. Now, I also wrote a scanner, and that's kind of cool. My first attempt at the scanner, what I did was I said, okay, look, here's the list of channels I'm interested in. I'm going to just tune from channel to channel to channel, listen in, and if I notice anything there, I'll stop and play it. What I could do down the road, and I've been thinking about this, is I can program the SDR to look at a wider range of channels and look at them all at once and say, wow, here's that, instead of scanning them, instead of having to tune channel to channel, look at the wide range and go, okay, bang, there's a signal here, go over here, give this one priority. And what people like the NSA do is they're looking at all the channels at once, and they're recording all of them at once. And then they go back and listen to whatever was interesting. It's a cool thing. Audio, I'm using ALSA for the audio. So I grabbed a cheap little sound card, and what happens is, once I've demodulated the signal, I dump it out as PCR and feed it to the sound card. In my case, in the Jeep, I have a little more complicated thing because I'm talking to the Jeep amplifier. So the output of these, the line, the rear and the front out, or in this particular case, the signal, the front out, goes to this this device. And so I have to tell the amplifier over CAN, oh, here's what the bass and the treble and the balance and stuff is. So I have to send it a CAN signal. So what's on the lower right-hand side, this 3D9, is the CAN address that I'm broadcasting to. So I'm broadcasting a message, and 2 bytes of the volume, another, 1 byte's of volume, bytes the fader, the bass, and so that when the amplifier sees that message, it knows to adjust itself and change itself. And it gets interesting when you have both the radio and this radio, the original radio and this radio in, because you're fighting the amplifier is getting 2 different messages and goes back and forth. Anyhow, okay. When I was done, I also said, gosh, let's add AirPlay. I want to be able to play music from my iPhone. Mike Brady wrote a great piece of code called SharePoint Sync that runs on a lot of Linux devices. They reverse engineered Apple's AirPlay. It's all on GitHub. And what I did is I've modified I use this AirPlay slightly differently than most people do. Most people just have it go directly to the output port or the ALSA port. And what I did is I pipe it. Instead, I've had it demodulate, do all the work it needs to do, and pipe it to a Unix pipe. And I pull it off the Unix pipe and feed it into my system, into my code. It also sends metadata. So in my particular case, I'm playing music and it shows the title of the music. Okay, so this is almost done. I need to speed up the boot time. So I need to get in there and fool with it a little bit, shut off the Wi-Fi, only leave, have it so that the device advertises itself as a Wi-Fi, but doesn't hook into my Wi-Fi network. I've done that a bunch of times. It's not particularly hard. I've considered using other variations of Linux. There's nothing specific to Raspberry Pi here, but it's just basically Linux. So I might try a different version, but I would love to speed it up. Right now, from power on. So I was telling you about listening to CAN bus. If I take the remote key and I hit the unlock button, let's imagine you're walking up to your car, you unlock it, you get in the car, or you open the door. Either one of those are going to start CAN activity. So the radio will start booting up, and it's kind of the way I cheat by having it boot up when it first sees the CAN activity. By the time I get in the car, the radio is booted up, because it takes you a couple of minutes unless you're really, really fast and trying to rush out of there. I could probably do some games where I don't shut down right away and say, gosh, I think I'll, the first time you boot up, maybe it goes into sort of a semi-state of sleep. Anyhow, what else is left? I need to finish the faceplate. I put a piece of plexiglass over the VFD, and I was thinking I should probably black out part of it so it just looks a little better. Put it in the dash, make this into a PC board. Okay, quick demo. Let's see if I can kill this. Quick demo. So what I did was, if I still have the screen here. Okay, let's let this run. So here it is. It's booting up. It does a quick self-test, and all right, fair enough. Here I'm tuning stations, and you'll see that. Oh, so if I double click on the button, I have this option of on the tuner button. I can say, tune all channels or known stations or presets, or if I have something in a preset, I can remove it. Basically the kind of things you expect. By the way, that little silver device on the right side there is the auxiliary connector. Sometimes you want to plug something in that's not AirPlay. So here I am tuning various stations, and you can see the little why I like the LED ring, because it's lighting up as I'm tuning. And I've mixed in my known stations or my popular stations, I've mixed VHF and FM. So sometimes I'll flip back and forth. All right, so when you click on it once, you get a menu that says, hey, what do you want to do here? And I've got a bunch of different settings. So in my case here, I hit the audio source and say, hey, I want to go straight to VHF. And so here I'm tuning VHF channels. These are the ones I've programmed in. All right, let's go back to and I could fine tune if I need to. And once I get a channel fine tuned, I can hit it and preset it and add it to my presets. It's just a table. I can go in there and edit the table. All right, let's see. Okay, let's tune a little more. All right, so audio, if you hit the audio options menu right there, oh, come on, just try that again. I'm fumbling my fingers here. Incidentally, the screen doesn't blink like that. That's because I'm recording on an iPhone. Okay, let's try this again here. Let's go to audio. Okay, and so, another menu I've created there that basically you can set these values. You want to set what am I going to set here? The balance. So this is all code, the changes. So what this is doing is it's actually sent. I initially wrote it so it would tell it did this in ALSA and basically faked what the balance was, figured it out, because it also doesn't have a concept of balance or treble. But now what I'm doing is I'm talking to the amplifier and telling it, oh, this is what I want to balance. All right. Oh, okay. So I said I wrote a scanner. So here's the scanner in operation. Again, use of the LED. It managed to catch a signal right here at the sheriff's office, and it's playing the signal until it's stopped and it moves. So I wrote code that once it gets something, it'll hold it for a couple of seconds. Once it's quiet, until it's quiet, and then move on like a scanner would normally do. This is me tapping on the this is me tapping on a GMRS transmitter, causing it to stop. And as soon as that's why those, and I can also like pick a particular channel that I programmed in and say, hey, these are the list of channels I want to scan. All right, whatever, let's move forward. Pick a particular channel. All right, so then I also added AirPlay. AirPlay is pretty cool. Just show you how simple this is. So go over to, pick up my iMac or iPad, what it was. I advertise as a Wi-Fi. So picked up that Wi-Fi channel, picked up that Wi-Fi SSID. And then as soon as you play, this thing picked up the music. There's about a couple of seconds delay while things buffer, and this is just part of the way AirPlay works. And I hit a different channel and it picks up. So as soon as you change your music, this is picking up. Now, incidentally, funny thing about driving an ASCII display is some of the characters have UTF-8. I happened to notice the other day when I was playing Blue Oyster Cult that Oyster is an umlauted O. So I had to write code to take UTF-8 and find the right ASCII character to display that. A lot of crazy stuff. Okay, talk a couple minutes about the GPS here. Oh, here, hang on. All right, so here's the GPS. Let's try an example here. Oh, okay, so this is where I happen to be at the time. How many satellites? I'm at 2,400 feet. I'm standing still right now. My dilution of precision is 0.6, so I'm getting good reading. And I think this one I did in my office. So that GPS device is picking it up through my roof, through my ceiling. It's doing okay. It's changing the altitude, but that's natural. It's going to bounce a little bit. Oh, I'm moving the right there. I was moving the GPS receiver back and forth, trying to see if I could get it to show heading or changes in speed. You need to move it quite a bit. Okay, if I pick out a waypoint, so let's say I want to, oh gosh. Okay, how far am I from Mount Ashland? I'm 12 miles away, 145-degree bearing, and that's the thing I'm looking at. I can add these guys. I can go to a place and add it in, or I can code one in. There's a little bit of there's a bunch of menu capability for there to do that. I mean, again, this is all you have to kind of hard code it with. Oh yeah, so here I am chasing a waypoint, and what you'll see is it's changing. It's saying, hey, 17 degrees, 19 degrees that way, 1.3, 1.6 miles. I'm closing in on it. There it is. I'm closing in on that thing. By the way, that's what I mean about I want to paint the background right there. You can, this thing is just sitting on my dashboard right now. It's Velcroed on. I'm trying to hold the camera. Okay, let's go up my hill. As I was closing in, there's a mistake right there. There's a bug I just fixed. You see the yards has too many, it didn't clear out the whole line right there. But 69 yards, I'm coming in. almost there. Coming up my hill, and bam, I'm 102 feet away from that particular position. I suppose I could do something like arriving, but all right. Couple more things to show the engine monitor. So here I am reading numbers from the engine. All this is coded in a table. These are pulled values. So or I have a list of like values that are known. So I have a table and I can say, okay, look, item number 4 is going to be volts. Let's see, 1, 2, 3, 4, 5, 6. Item number 6 is volts. So I'll display the volts there. Like it knows what the thing is and how to properly display it. There's my 2 data buses. I'm showing how much activity I'm seeing. I had to fake a diagnostic here. I had to fake some errors. So here I'm sending it a packet saying, oh, check your engine. Okay, well, let's see. Go to diagnostics, and bam, you've got a whole bunch of error codes all at once. What are these things? Oh, okay, someone disconnected the oxygen sensor. Okay, let's see. I think, yeah. Get rid of those codes. And one more screen. I just said, okay, what is the thing here? I'm a geek, so like you need to know stuff. Like, well, how hot is the CPU running? What version of Linux am I running? All that other crap, just cool, useless stuff. Because I like having about boxes. All right, and I think we're almost there. Yeah, I think so. All right. How do I unshare? Let's see. We are now pause share. Stop share. Okay. All right. That's about all I got to say right now.
It's very cool. Do you use it every day?
Say again. Do I use it?
Do you use it every day? And is it a regular thing now?
I'm in between. I'm almost installed. Pretty close. I want to fine tune the antenna a little bit. For example, my antenna is just it's just a dipole that I put together out of. It's disgusting here, but I suppose I could use the car antenna, but right now it's just this little dipole that I made, out of a piece of wire, and I want to fine tune this a little bit. I'll get better at it. As soon as I have that done, let's put this back up here. Okay, as soon as I have that done, I think I'm just about ready to tear it apart. It's kind of cold here now. It's wintertime, so I don't really want to work outside in the car. The point behind the project, and the reason I really want to talk about it, was that there's a lot of little subcomponents of this project. And I think I pushed the Raspberry Pi to the limits on some of it as far as interfacing, that you could take any one of those things and use yourself, the one wire stuff, the SDR stuff, the knobs, and decoding knobs are pretty interesting project on its own. Yeah. Radio My Golf takes an age to boot. Yeah. So another area that's going to be interesting is speeding up the boot time, and I'm trying to work on that right now. I've seen a bunch of folks work on that. But what I really would love to do is to find software, an OS that could handle sleep. I mean, again, this is just Unix code, right? So Linux code. So it could be anything.
We thought about making a hand portable.
Oh,
like use much of the same code, but
yeah. That's a really cool idea, because there's having So what I would do with that is I would take the GPS and I would take the SDR. And one of the coolest things I've seen someone do is they create a heat map. So if you go look at that course I was referencing, what you could do is, for example, one guy was walking around trying to find the police that were running a shark. It's not a wire shark. You know those devices that pretend to be cell phone towers. He was running around and trying to follow the signal. So he managed to, as he would go driving around town, he drew a heat map, figured it out, put it up on a Google map, figured out where the signal was coming from, and then narrowed it down to this police car that had run a fake cell tower. But things like that, like I have a real legitimate use for it. Somebody in our neighborhood has he's got a scanner or a transmitter, and he occasionally at certain hour of the day, his dogs bark. And so let's see if I can make this happen. So you'll hear this. Let's see if it plays. No. I don't know if you can hear that, but that barking goes on over the sheriff's band. And so I was driving around Sergeant the other day. We're trying to narrow down and pick up where this thing was, and it occurred to me. That it was just driving the sergeant crazy. So it occurred to me, this would be a cool project for Raspberry Pi with an SDR. Ultimately, what I did to the sergeant, because it was driving him nuts, was I hacked his phone and put made that his ringtone. But that's just the kind of stuff. But you have a really good point there, right? Having it as a mobile device, and doing stuff like driving around and war hacking, for Wi-Fi or for I said you could read gas meters, you can read utility meters. I mean, I'm trying to find legitimate uses for it, but and in the US we don't have a restriction about receiving transmissions, but I still think that there's got a lot of potential like that. That's a cool idea. It would be neater to make it simple, and then I wouldn't have to do all the whole power management stuff, turning on and off CAN bus, none of that garbage. Just a GPS and a radio, and you could use the OLED display. That would be fine. Wow. Okay. Neat project.
Yeah, I was just wondering also about the how you found the screen. So you're just doing ASCII characters, but does that
It's a
speed up your
mix.
development time significantly? Because it's sort of
So it's a mix. I'm using. You can tell the screen certain commands, like you can say clear the screen, set the cursor, dump these ASCII characters, but then you can also say, plot these little points. And so some of the things like the diagram with the signal strength, or you'll see I have a scroll bar that's graphic that I've had to write. Incidentally, go and write a scroll bar code that it just so happens I come back from that old generation of computers, so we've actually had to write the scroll bar code. So, that whole framing and stuff, that there's a bit of magic in that.
it's an interesting choice, isn't it? To go for one of those screens where.
It is, yeah. Again, I wanted
like the retro bit.
Retro. Yeah, I
Yeah.
really wanted to look retro. And again, people don't have to do that. You can just do whatever.
I like projects that have like a lot of a modern back end, but sort of like a retro front end. It's very,
And I
very
think
cute.
that's the thought, is like, someone could walk up to it and say, well, what's that? Again, other interesting thing, there's two holes in the front of the screen to hit for power on, a power off button, that you can stick a nail in there, because every now and then it's going to break and need to be force reboot, right? It's software, right? It's still in play. Okay, one more interesting point was the reason I'm really careful about the Wi-Fi is I don't want people hacking me. So I initially wasn't going to put AirPlay on the same device. I tried. My first crack was to take AirPlay and put it on like a little Pi Zero kind of thing, and then take the audio out there and feed it into this thing. And they're like, this is too much work, but that would have been an interesting form of isolation, right? If you hacked the device, you would have just hacked the AirPlay device. What I've done instead is I've just gone in and, spent time looking at what ports are open and looking at the code that's the AirPlay code to make sure there's nothing, the buffers are, it's, I basically ran it through an analyzer to make sure there was no buffer overflow potentials. That's something I recommend anyone to do is run it through some kind of LLVM has a bunch of cool analyzers. That's a topic in its own analysis for hacks.
Yeah, I definitely found
But
the SDR part of it very interesting.
So
Like to play with
take
that.
a look at what Michael Osman has done. The great Scott Gadgets guy. His description of how SDR works is fascinating. Like, and he walked, and I guess the Stanford course. What I was doing is look at the notes of the Stanford course, like the lab notes, and that's the cool part. Even if you don't want to do any SDR, just look at what you can do. That's pretty cool. But they reference Mike Osman's stuff, and the story behind it's rather cool. Somebody figured out how to use a TV receiver, how to hack a TV receiver, and get data off of it, and then it just went from there. And it's one of those pieces of magic today. Like if you can do that, you can do anything. Once you can read. Oh, and there's SDR transmitters too. Right. So for example, you can sit there and listen to the key codes coming off of a car key and then play it back. And a lot of them don't have replay protection. There's scary stuff like people have done. I know of at least one Chinese hacker who's done code to try to hack through the tire pressure system and hack into the data bus, into the main bus through the tire pressure system. And I don't know the details on it, but that's really scary what you can do to a car. Once you get into the CAN bus, if you get into the internal bus. I think Chrysler learned a lesson and tried to firewall some of their buses from the outside world, but realize that things like OnStar can still talk to your car data bus, and so there's a lot of damage that you can do from OnStar, even if you don't subscribe to OnStar. Yeah.
Any other questions, anyone? Unmute yourself.
If somebody wants to help me out with the power board sometime, or the front panel board, and help me make a PC board, if I know somebody was going to talk about doing manufacturing, I would love to take something like the power management board, because I know other people want to do things like this. There was one guy who had like a device for cars that would turn on and off, but it was so poorly designed. It was just like really, he doesn't take advantage of the CAN bus. One of the things I have in my Jeep is I have rock sliders on the side, and because the Jeep is so high, the sliders will drop down and give you a step. So like when my wife's wearing her heels and she needs to step in, or skirt, and she needs to step into the car, she doesn't have to reach up so far. So the way it right now, the guy used little magnetic sensors in the doors. When the doors open, the thing would open an actuator and drop the sliders down, the steps, right? Drop steps down. The magnetic sensors constantly break. Things slam on them. They get hammered on, and so, but the car knows when the doors are open. So the right thing to do is to just listen to the CAN bus. So I'm going to rebuild his little device and drive the actuators with that. But just listen to the CAN bus. And that said, I have a little Arduino, AVR, and underneath it is a little CAN bus receiver, a transmitter. And this right here, I mean, it could be smaller, right? But and a little OLED, and I put these two guys together, and I'm able to like look at CAN bus and display things. It wouldn't be too hard to drive a relay with it, and a couple of relays and flip the actuators back and down. I need to do some electronics to figure out how much current is going through the actuator. Because one of the tricks there is to, if you get your foot caught in the step, you want it to stop while you're moving, so it doesn't close up and like, you know, slam your foot into the step. But you know, that's just another project. So yeah, these are cool stuff. I mean, there's a lot of things you can do with cars. There's a lot of little side projects here. Yeah.
Yeah, it's like it's a very meaty project, isn't it? Lots of things going on there. So any other questions from anyone else? Yep. So yeah, don't forget look at Vinnie's Substack. There's lots of really good articles in there. Cool. If
Cool.
there's nothing else.
Well, let me know.
Thanks.
Let me know when you post the video.
Yeah, will
I'll
do.
pass it on to someone. Thank you so
Thanks
much,
so much.
guys.
Thanks so much, Vinnie. Very good.
All right.